This is Algebra 1, and today we're looking at equations with variables on both sides. You pretty much use the same things you use when you solve simple equations for complex equations. It's just one or two more steps, and this may be something you haven't seen before, or maybe you have seen it and you just need a refresher. When you have a variable on both sides, you just want to get rid of one. And I think the easiest thing to do is get rid of one of the variables before you start solving. I like to get rid of this. It depends. Some people like to keep the variable on the left-hand side, and that is okay. I kind of like to keep the variable positive. So what we have to do, we have a positive 3x here, and if I want to get rid of a positive 3x, that's just some numerical value. I just subtract it, because 3x minus 3x equals 0. And I subtract it on both sides of the equal sign. That's why we have the line here, just to kind of keep our logic straight. We want to make sure it's on both sides of the equal sign. 5x minus 3x is 2x. Bring down the minus 2, bring down the equal sign, which is on the line, and bring down the 6. So now I'm down to a two-step equation. Add 2, we get 2x equals 8, and the last step would be division. Show division like that with the division bar. We get x equals 4. Okay, and there's our first answer. Look at the next one. It's similar to that. When you have an x by itself, you have to think of that as 1x. The coefficient of a x that's by itself is 1. Okay, I like to keep the x positive, so I'm going to get rid of this one. To get rid of a positive 1x, you just simply subtract 1x, and I want to do it on the other side of the equal sign, just like this. Okay, so 1x minus 1x goes away. I bring down this negative 1 right here. 9x minus 1x is 8x, and I've got plus 15. Okay, again, you're down to a two-step equation, so it's pretty simple from here on out. Minus 15. Minus 15, negative 1, negative 5. The signs tell us to add, same sign sum. So negative 16 equals 8x. And we're going to divide by 8. And we get x equals negative 2. X equals negative 2. This one requires one more step, or two more steps, actually. We're not really going to worry about this sign for a bit. We need to do a little housekeeping over here. So we want to simplify. We want to get it down to two things, okay? The first thing would be to get rid of the parentheses, so I'm going to multiply, and then multiply, and we get 12 here. Then you just bring everything else down, okay? This is multi-step, and we're just going to do each step and make sure we're correct about it. Okay, so I cleaned out the parentheses, which is the first thing you always want to do. Now I want to get rid of, I want to actually combine like terms. So I've got an 8 and a 12. Those are both constants. I can get 20 with that. Okay, 20 plus 6x, I got 3x minus 7 over here. Now, this looks like something we've already done. Okay, it took a couple of steps to get there, but it looks just like something we've done. Now, I want to get rid of one of the x's. This is a 3x, this is a 6x. I'm going to subtract 3x. Okay, that makes that go away, and you've got to bring down the minus with the 7. It's a negative 7. Bring down the 20, and this is 3x. Okay, again, I want to subtract 20, same sign add, same sign studied add, so it's negative 27. That's going to equal 3x. And the last step is division. Divide by 3, x equals negative 9. That looks like a G, but hey, my writing's terrible. Okay, moving on to the next page. I'll come back to the decimals here in a second. Now we have parentheses on both sides, and it's just a matter of clearing them both. So we just multiply 10x. Multiply negative 2 equal, okay, multiply 3x, multiply 33. Okay, now we have to pick one of the variables, may go away. I'm going to make the 3x go away, so it's positive, I subtract it. If it were negative, I would add it, but I'm subtracting. 10x minus 3x is 7x. Bring down the negative 2, bring down the 33. Okay, now we just have a two-step equation. I'm going to add 2. I get 7x equals 35. Divide by 7, x equals 5. Okay, just like that. If you're dealing with decimals, it's not that much harder. It's just kind of a pain sometimes, especially at the end when you have to long divide. But again, you just pick one of the variables to make go away. This is a negative 1.15x. So I know I have to add it, and I would like to add this more than I'd like to subtract that. So I'm going to do that on both sides. And you need to line up the decimals when you do that. Don't forget to do that. So it's 1.15x, and we're going to add. Okay? Now I'm kind of right over this. We got to add a placeholder. You don't really have to do that, but you know, for your help. 5 plus 0 is 5. 1 plus 1 is 2. 3 plus 1 is 4. So you get 4.25x plus 9.2 equals, and I'm kind of getting tight here. Let's see, 2.06. That's gone. Okay. The next step, I want to get rid of the 9.2. So I'm going to subtract 9.2. And when I subtract 9.2, this is positive and it's negative, so you have to actually subtract them. But since I am going to subtract them, I'm going to put the 9.2 on top, because you always want to subtract the little smaller from the larger. So I put that on top. I'm going to put a placeholder here. It's getting a little tight to see, but this is kind of what I'm doing. 10 minus 6 is 4. I borrowed one from that. That's going to be 1. And that's going to be 9. That's 7.14. Okay, when I subtract that, the biggest number is negative, so I'm negative here. And I'm going to bring down this 4.25x. Okay, now the last step is division. You get 4.25, 4.25. I'm not gonna, you would do some long division here. I'm not going to do that. I do think I know what the answer is here. But this is the way you would do it, and you don't want to see me long divide anyway. You may not want to see me do any of this. I don't know. So we're going to move the decimal, and when you divide, I think the answer, don't hold me to this, but I think it's negative 1.68. Okay, it is negative because there's one negative here. But when you long divide, you get 1.68. Okay, next page. When you have variables on both sides, sometimes you get to special situations. And in this case, the first one, if we do this and we do this, we notice something. And that is that we have the same variable on both sides, but a different constant. So 10x is just a numerical value. If x was 2, that would be 20. If x is 3, it's 30. We don't know what the numerical value is. But I do know this. I can't add 5 to a number and it equal the number you start with. There's no way you can add 5 to 10x and it equal 10x. This could never happen. So we just call that no solution. When you see that, you would just simply write no solution. That means no, there's not a single number that works in this equation. No solution. Out of all the numbers, infinity, it doesn't work. Okay, so the other special situation we have is this one, where you actually multiply here, you get 6x plus 2, and you get the exact same thing on both sides. An identity equation where you have the expression on both sides is exactly the same. They are identical. When that happens, you have not one solution, but infinitely many solutions. In fact, every number you put in there works. So it has an infinite number of solutions. You can call it identity equation, or you can say it's infinitely many solutions when you acquire something, when you have something like this. So you really don't have to go any further than this. When you see they're both exactly the same, you can just write infinitely many solutions or identity equation. The signs have to be exactly the same also. Everything has to be exact. Okay? Let's look at a word problem. Okay, it takes a graphic designer 1.5 hours to make one page of website, probably important. So 1.5 hours per page. Using new software, the designer could complete each page in 1.25 hours. That's 1.25 hours per page. That is a rate also. But it takes 8 hours to learn the new software. How many web pages would the designer have to make in order to save time using the new software? So X is the question. How, and this is my handwriting again, many web pages. That's X. Okay? So we're going to compare this to this. Okay, so if I do 1.5, if it's 1.5 hours per page, and this is how many web pages, it's going to be 1.5x. We're going to compare this to 1.25x plus the 8 hours it takes to learn the software. We're going to set them equal to each other. We're going to find out what that number is so we can answer the question. So again, we have decimals, but not a big deal. This one isn't too bad. I want to get rid of this x. If there's two x's and one constant, get rid of the x with the constant. So I'm going to get rid of the 1.25 minus 1.25x. When I do that, I'll put that 0 there. 10 minus 5 is 5. That's going to be 2. Bring down the decimal, and that's it. 0.25x equals 8. Last step, divide by 0.25. Divide by 0.25. Okay, and that gives us x equals 32. Okay, so at 32 web pages, they're exactly the same. To save time, it has to be more than 32 web pages. So it would be, you could say 33 or more. Because at 32, you're not saving any time. It's the same time for both. So to save time, you need to make at least 33 web pages. Okay, and that concludes our discussion.